We continue to look at indices as well as logarithmic and exponential functions. Now, in a previous video, we looked at solving a few equations or a few functions. Let's look back at this. We said 2 raised to the power of x is equal to 16. 2 raised to the power of x is equal to 32. 2 raised to the power of x is equal to 25. Alright? We see that this one here, the 2 raised to the power of x is 16. In fact, what we want to do is find the value of x. So let me write it up here. We're finding x. You could consider 2 raised to the power of x equals, and you know that 2 raised to the power of 4 gives us 16. So you write 2 to the 4. So if 2 raised to the x is 16 and 2 raised to the it is equal to 2 raised to the 4, then x must be 4. So x equals 4. You see that? Now, we could very well use logs to do it. Let's say you log both sides. We're going to use natural logs because in more advanced mathematics, that's what the concentration is on. It's on natural logarithms. Now, say we find ln. Let me rewrite that. Let's write my L like this. ln, you know, it's lowercase l when it's written. Whenever you see it written, whether on a book or in a book or a website, it's lowercase l, lowercase n. ln 2 to the x is equal to ln 16. Now, you remember that ln of 2 to the x would be x ln 2. The ln of a number raised to a power is equal to the power times the ln of the number. And we discussed that in a previous video, right? We discussed how you form the 3 rules of logarithms in a previous video. So here we say it's x ln 2 equals ln 16. So if you divide both sides by ln 2, then ln 2 will cancel itself, so you get x is equal to ln 16 divided by ln 2. Alright? And when we draw for our calculator to find ln 16 and divide it by ln 2, what we get is ln 16 over ln 2. Right? So what we have here, ln 16. Oh, I did ln 6 over ln 2. Let me make sure it's ln 16 over ln 2. It's ln 16 divided by ln 2 equal, and you get 4 as your answer here. So you could very well solve it using logarithms, or you could use just indices and equate both sides. Here in this case, both sides of the function can be equated in terms of indices. Alright. Now, you could also very well use indices, easily use indices, or logarithms for this one. You say 2 to the x is equal to 32. But you can consider 2 to the x is equal to 2 to the what power gives you 32? Let me see. I know you can raise 2 to a power, a whole number power to get 32. 2 2s 4, 4 2s 8, 8 2s 16, 16 2s 32. Alright, if you have 1, 2, 3, 4, if you have 5 2s written down and all of them, you multiply one another, you multiply each other, you get 32. So it's 2 to the 5 that gives you 32. So therefore, x would be equal to 5. If you do use logarithms, what you do, you find ln of 2 to the x equal ln 32. But this is x ln 2, and x ln 2 would give you ln 32. So when you divide both sides by ln 2, you get x would be ln 32 over ln 2. And what would you get for that? Let's draw for our calculator. So what we have is ln 32 divided by ln 2, and we get 5. Alright? So we get 5 for our answer. The thing is, you could very well also use common logs. You could get log 32 divided by log of 2, and you get 5 just the same. Alright? Whether common logs or natural logs, whichever one that will work out. Alright? Remember also, natural log has a base of e, where e is this number 2.718 to 3 decimal places. Common logs has a base of 10. And when I say log, it means logarithm. It's just a short way of saying logarithms. Instead of saying logarithm, you just say logs. You save time and energy when you say logs instead of logarithms, and if you're writing, you're saving ink. But anyway, when it comes to the 2 to the x equal 25, it's not so easy and it's not so quick trying to equate both sides using indices, solving it by indices. So don't even bother to try that. Just go straight for logarithms. What you have here is, let's use ln 2 to the x equal ln 25. So this is same as x ln 2 equals ln 25. When you divide both sides by ln 2, you will get x equals ln 25 over ln 2. What does that give you? Let's find out. We have ln 25 divided by ln 2 equals, it's 4.64385 and so on and so forth. If you use log, common logs, it's same thing that you will get. Log 25, log 25 divided by ln 2, and you get the same thing, 4.6438 and so on. To 3 decimal places is 4.644. Alright? So let's write that down. 4.644. If you should raise 2 to the power of that, you get 25. Let's say you have 2 raised to the power of 4.64385,619, as you see here, equals, you get 25. Alright? If you use the 4.644, you'll get close to 25, but not exactly because of the rounding off. So it's 2 raised to the power of 4.644 equals, right? You get 25, very close to 25. All right, so those are what we have here. All right, so these are logarithmic functions and exponential functions, and we can solve them using logarithms.